characters, strings, and math functions. Let's go. Let's try this again. Wish me luck. Let's make sure we take that off. Java allows you to process characters using the primitive char data type. Remember, we have 8 primitives. We've covered int, double, we've seen float, boolean, and now we have the char data type. So before we even begin too much, let's come over here to NetBeans, make a new project. We're at chapter 4, so let's call this chapter 4 notes. Yeah. And so let me zoom in really far so y'all can see this when you're watching it. And I can make a new char data type right here. Char some character. And I can save inside a pair of single quotation marks, not double, single quotation marks. I can save one character, the letter B, for example. That is a single character. It can be an alphabetical character. It can be a number, a numerical character. It can be some other character. I can save a left arrow into that variable some character. So this is the char data type. It's a primitive. It's not an object. It's not made from a class. It does not have methods that operate on it. It's a primitive data type. So it has a small memory footprint and it's used for speed and efficiency. We can save a single character and it must be enclosed inside a pair of single quotation marks. So if I try to put 2 characters, not just A, but A and B, that'll give you an error. If you read the error, it says unclosed character literal, not a statement. Doesn't even make sense. Bottom line, it can only be a single character. If you want to put, for example, double quotation marks instead of single quotation marks, now you're going to have an error. That's not a char. That's a string. That's going to be covered in just a bit, in maybe 15 or so minutes. So we put a single character within single quotation marks. So we want to be able to talk about characters, how they ultimately map to what gets coded on your computer. Remember, the computer only understands ones and zeros. So we need to unfortunately take a brief hiatus. Now that we're a bit more mature, we have a single, at least one programming language under our belts. Hopefully, I hope, fingers crossed, we're a bit more prepared to accept learning about encoding schemes, ASCII, Unicode, and more. Now what this means, let me turn on the laser pointer. We're going to cover character encoding. We're also going to be, which means covering a refresher on bits and bytes, which people are like, oh no, and let me join you. I'm crying as well, oh no, perhaps. We need to do a refresher on binary, on hex, on decimal. These things are going to be important. Maybe the crying goes to something other than crying, and maybe we want to give up, but I'm telling you, it's not going to be that bad at all. No, Luke, it's not going to be that bad. So Unicode and ASCII code, these famous encoding schemes, why are they here? Computers only understand electrical signals, ons and off, which we then translate. It makes it easy. We use 1 and 0, the binary counting system. 2 choices, 1 or 0. So computers effectively store these binary numbers internally. And why is this important? Because clearly we don't want to code in just ones and zeros. If being a developer meant we had to understand whatever this meant and now we come to the next line and we keep on going, not only would I not be here teaching it, you wouldn't be here learning it, we would all quit. There's no way that's sustainable, right? So thank God that we have high-level languages that have been created that use more than ones and zeros, right? Python, Java, the C languages, many more. They have commands, English-like commands, print, P-R-I-N-T, these characters making up the word print. So they're much more than ones and zeros, which means what now? We have to have a way of mapping those characters to a set of ones and zeros that your computer will understand, that my computer will understand, that any computer universally will understand. If you type the letter B, as in Bob, that letter B should map to a set of ones and zeros that will be universally understood by any computer in the world. And that is called an encoding. a way of mapping a character to its binary representation. And it turns out there's different ways of encoding or making these encodings or have these different types of coding schemes. The most famous and one of the original ones is called ASCII. What is ASCII? ASCII is a 7-bit encoding scheme. And what does that mean? That means that 7 bits are used to represent a single character. Example we have here, 1110111. I had to check that myself in code to confirm, but that is a W. 011011, believe it or not, that is the number 7. And notice that each one of these is a 7-bit encoding. There's 7 bits being used. Remember, a bit is either a 0 or a 1. There's 7 bits being used to encode this 7. How many different characters can you encode with 7 bits? Let's take one of those brief moments of pause and look over here. If we have 7 bits, so 1, 2, 3, 4, 5, 6, 7. And each one of these spots can be a 0 or a 1, a 0 or a 1, a 0 or a 1. Each one can be a 0 or a 1. And the question we want to answer, how many total number of different 7-bit numbers can you make? And before answering that question, let's answer a smaller one. Let me go back one. Let's answer a smaller question over here off to the side. What if we only had a 2-bit number? Remember, this can be a 0 or a 1. This can be a 0 or a 1. How many different 2-bit numbers can you make? Well, you can have 0, 0. You can have 0, 1. You can have 1, 0. And you can have 1, 1. So how many different numbers did we make? The answer is 4. We made 4 different 2-bit numbers. Now, that was easy because it was only 4, right? Well, here, if all of them were 0, well, I could make a 7-bit number where everything's a 0. I could make a 7-bit number where everything is a 1, right? Well, how many different 7-bit numbers can you make? It turns out you can make 128 of them. Now, how do you get that number, 128? Well, here, we say we can have a 0 or a 1 right here, right? We say that can be a 0 or a 1. That really means there's 2 possible options. And there's 2 possible options here, there's 2 options here, 2 options here, 2 options here, 2 options here, 2 options here. And so that's a choice. It's really a binary choice. You can make it every single bit. And so what you do is you multiply those number of choices together, and you end up with 2 raised to the 7 power. And it turns out that that's the number of bits. So over here, we had 4, right? Well, what is 4? It's really 2 raised to the 2, the number of bits that we chose. It was a 2-bit number, which gave us 4 possibilities. Well, this was a 7-bit number, and 2 raised to the 7 is 128. That's one way that you can come up with how we got that answer. And we'll see another way in just a bit when we remind ourselves of how we convert from binary to decimal. Or you know what? Let me go ahead and give that reminder now. Let me make a new notes. No, how do I do this? Let me just erase everything. All right. What if I want to, another way we can come up with that 128 to see what we remember. I'm not here to teach how to convert from, that wasn't my intention, how to convert from binary, sorry, let me erase this, from binary to decimal, but let's just look at an example, see what we remember. If I gave 1, 1, 1, 1, 1, 1, 1, 1, what does this add up to? That's going to be a big number. Well, I want to see what you remember, that this first bit, it has a value of 1. This next bit has a value of 2. This next bit has a value of 4, and it keeps doubling. This bit here has a value of 8. This next bit has a value of 16, 32, 64, and then 128. And if you add all of those together, 128 plus 64 plus 32 plus 16, add all of that together, you're going to get 255. So this number here adds up to 255. Now, how do we do that? Well, all you do is you remember that this first one has the value of 1, the next one has the, and then it just doubles. Then we have 2, 4, 8, 16, 32, and it just keeps on doubling. The next one would have been 256, the next one would have been 512, and then 1024, 2048, and so on. So what happens if maybe this was a 0 right here? Instead of having a 1, what if that was a 0? Let's say this was a 0, and let's just say that this was a 0. So here, this was a 0, this was a 0, and this was a 0. What's the value of that binary number? Well, we're going to look at to see up here what's a 0 or a 1. And if it's a 1, we need to include in our decimal answer, we need to include the value shown down here. So basically, let's look at all the ones that are a 1. This is a 1, this is a 1, this is a 1, this is a 1, and this is a 1. So what we do is we ultimately have 128 plus 64 plus 16 plus 2 plus 1, and that's how we calculate that binary number. That's just a brief reminder on binary numbers. It's valuable how you compute the decimal value of a given binary number, and you're going to see why this is important as we go through more examples. So the following page shows the full ASCII encoding. And this is 127 different characters that are encoded in this ASCII encoding. Let's look at, for example, we have here the capital letters are from 65 to 90. So A, right here, here's capital A all the way down to capital Z. Capital A has the decimal value 65, and it goes all the way down to capital Z, has the decimal value of 70. Now for clarity, let me come back to the tablet again. So we just saw that A, capital A, has the decimal value of 65. So I'm going to put base 10. Now this is a 7-bit encoding. So how do we get 65? Remember, this would be a 1, this would be a 2, a 4, an 8, a 16, a 32, and a 64. What combination of those numbers would make 65? Well, clearly 64 is going to be valuable. And then really 64 plus 1 is 65, and all of these other bits would be 0. So it turns out that capital A is really 1, and then how many zeros? 1, 2, 3, 4, 5 zeros. And this is base 2. So in binary, 1, 0, 0, 0, 0, 0, all those zeros, and then followed by a 1, is the capital letter A, which happens to be 65 in decimal. So the value of this is it helps us to understand. We come back over here to this ASCII table, and we can see, okay, so A, universally, in any computer around the world, it ultimately is 1, 0, 0, 0, 0, 0, 1, also 65 in decimal. Capital Z is 90 in decimal. Lowercase a is 97 in decimal. Lowercase z, it goes all the way down to 122. We have the numbers right here that are 48 all the way to 57. This is the ASCII table. Important for us to understand that we have this encoding scheme, one of the original ones. It was a big deal. It meant that all computers could understand the exact same encodings when people are typing on a keyboard. As a developer, you type the capital letter A, it's always going to be translated to 10000001 everywhere in the world. So that's great. What's the limitation? The limitation is that that's a typo. There's only 128 different encodings. That's it. That's not very inclusive of other languages, other cultures. It basically covers English, uppercase, lowercase, numbers, the things we see on a traditional keyboard. So Unicode entered the scene and came to the rescue. What is Unicode? Instead of being a 7-bit encoding scheme, it was a 16-bit encoding scheme. So now you take 2 raised to the 16th power, you get 65,000 different characters that you can make with Unicode. That's a lot more inclusive than the 128. Again, that's a typo. That should be 128 characters encoded by ASCII. Now, even then, is 65,000 enough to cover all languages and all possible characters in every language? Maybe not. In which case, Unicode has even an extended version with over 1 million different types of characters that can be encoded. Also important is this bullet point to know that Unicode includes the original 7-bit encoding scheme. So the first 128 values in Unicode are actually the original ASCII. From the 65,000, the first 128 values are the original ASCII encoding scheme. Then we have the new Unicode characters afterwards. Now, for simplicity, for the remainder of this discussion, we're just going to talk about the 16-bit encoding of Unicode. So with that in mind, a reminder, one bit is a 0 and 1. We have 8 bits. That makes up our byte. So if I told you that we have a 16-bit Unicode encoding scheme, that means we have 2 bytes that are required in order to store a single Unicode character. And guess what? You can actually represent this, encode this using both binary and hexadecimal directly into your code. You're not going to want to do that, but I just want to cover this. Obviously, coding in binary is way too cumbersome. So I hope people remember why we learn hexadecimal. And it's not actually a pain to understand hexadecimal. Rather, hexadecimal is extremely valuable. Once you recognize that things on the computer are stored in zeros and ones, you wouldn't want to be typing in zeros and ones, especially if you look at full stack developers that are dealing with code with colors on a web browser. Colors are ultimately represented in zeros and ones. No one wants to say, oh yeah, I need this special color of blue. It's 0 and 1, 0 and 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 1. That'd be crazy. Instead, if you just say, oh, my blue, yeah, it's A4, 3E, 2, 5. For example, that's a lot easier. That's still hard. You got to remember that, right? But that's a lot easier than all of these other binary numbers. So we have this table as a reminder to convert from decimal to binary. Most of us have seen this, perhaps even memorized it. You probably know how to make this table very quickly. This is obviously 0, 1, 1 0 is 2, 1 1 is 3. You've seen this. Here's 7 all the way down to 15. Now, why do we traditionally go from 0 to 15? Remember, including 0, this is 16 different numbers because that's hexadecimal. Hexadecimal is a number system with 16 values. So we have 0 all the way to 9. And then this here for 10, it's really A, followed by B is 11, C is 12, D is 13, 14 is E, and 15 is F. So hexadecimal allows us to very succinctly convert from a binary value to its hexadecimal equivalent, which makes things super, super easy. So as an example, here's 16 bits in Unicode. Imagine we have a 16-bit binary number. No one wants to remember that. But if you can group each of the 4 bits, if you take each 4 bits and put them into their own group, so this first 4, 0, 0, 0, 0, the next 4, 1, 1, 0, 1, the next 4, again, 1, 1, 0, 1, and the final 4, 0, 1, 0, 0, and then you merely convert each of those to hexadecimal using this table, right? We know that 0, 1, 0, 0 is in fact a 4. You can see that. We know that 1, 1, 0, 1, come back to the table. 1, 1, 0, 1 is 13, which is going to be a D. And so if you make each of these individual conversions, we see we end up with 4D0. That's a lot easier to represent than all of these ones and zeros in binary, which is complete trash to try to represent. All of that said is just to let you know that we can represent a single character in a char primitive data type. I can put, as I showed you, just an alphabetical character. I can put the alphabetical lowercase d. Let me then print this, some character. I can put a number, as I showed you. Let's put the number 2. I can print that. But here's what's interesting. I can specify an exact Unicode value here. And what I do is I need to give the 16-bit binary number, but in hex. So let's come back to the tablet and let's actually erase this very quickly. We already calculated A there, as we saw. So we just saw that A was what? A was 1, 0, 0, 0, 0, 0, 1. Let's confirm that. This would have been 1, 2, 4, right? 1, 2, 4, 8, 16, 32, 64. So this is 64, plus 1 is 65, which, yes, we already confirmed that is in fact A. Just deleted some zeros. So that's A. But now this is only 7 bits. Unicode is 16 bits. That means we need to pad the left side of this with all zeros, right? So I need to make 16 total bits in groups of 4, where this is the rightmost portion. So let's do that. So here, I'm going to take these 4 bits here, and I'm going to put them right here as 0, 0, 0, 1. I'm going to take the next 4 bits, which here's 3, and then the 4th one is a 0. I'm going to put this here, 0, 1, 0, 0, and then all of these are just 0, which are coming from these, right? So now we have a 16-bit Unicode value, and we can convert each of these to their hexadecimal equivalent. Obviously, that's just 0. That's just 0. This is just going to be 4, and this is going to be 1. 0, 0, 4, 1. So guess what? When I come over here now, and I put 0, 0, 4, 1, I'm telling Java, hey, I'm giving you the exact Unicode binary value, but I'm displaying it in hex instead of putting all of those zeros and ones and zeros, which is crazy, and run that, and guess what? Oh my gosh, I now print an A. Way overkill, way more than you probably ever wanted to know, but it is important because now we can encode all kinds of characters, not just uppercase letters, lowercase letters, numbers. You can encode all kinds of things. One thing you've seen moving on was escape sequences. We've seen this in Python, where what if we want to be able to actually print this print statement? They said that Java is fun. What happens if you wanted to compute, if you wanted to actually print this exact statement, right? We want to print a quote. They said that Java is fun. And you want to make that statement. What's happening? Why is there an error? Because this first quotation, what it basically says is that we're starting a string. You're basically telling Java here, we're starting a string. T, H, E, Y. Print all those things. Print the said. Print the space here. Print the next T, H, A, T. Print another space. But when Java sees this double quotation mark, it says, ah, that's the end of the string. Great. But now it sees this stuff and it's confused. Wait, what are you doing? Now we know we want to print this double quotation mark. We don't want to actually count it as the end of the string, right? So what do we have to use? We have to use what is called an escape sequence. And we've all seen this in Python. The solution in Java is identical, that we would have come in here and put a backslash. What this backslash does is, let me go through this again. We're printing. Java sees an open double quotation mark. It says, I got you. No problem. Got you. We're going to print a string. So it starts printing the string, character by character. Printing, 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 printing. Print the A, print the T, print the space. Now when Java sees this, it says, whoa, I see a backslash. So the next character that I'm going to read is going to be important. I need to do something different than that. Oh, you put a quote? Gotcha. You want to print a double quote. No problem. And we then get this result. They said Java is fun when we run our code. We've seen other escape sequences. That's what these are called. When you put a backslash and you put some other character afterwards. What if I wanted to print on one line? I want to print ABC with one statement, but I want A, B, and C to all be on a different line. We've seen this, right? I can put a \n, and now I'm putting each one on a different line. That's a \n. I can put 2 extra lines between each one, and now I get this in the output. We've seen escape sequences. We can use a tab. I'll end with a tab. Here's ABC, we run it. I can even put here a \t, and this will print a tab as an escape sequence. And it'll just put a tab in the output. That's a tab. Pretty straightforward, right? Okay, now we get to the character class. Remember, char is a primitive data type. The consequence is that since char is not an object, there's no methods that can operate on it. So the question then, how can we run tests on characters? How can we test if a character is uppercase or lowercase, or if it's a digit or otherwise? The answer is Java gives us what is called the character class. This character class, it has methods inside it that are service level methods. We call them static methods. They're methods that serve you. You want to send over a parameter to that method and check, is this an uppercase letter? Java has your back. You want to send over a digit and check if it's a digit? Java can help you. These methods are provided in the character class to serve you in your program, and they're service methods that are called static methods. That's the first time we're hearing this word, static methods. What is a static method? It's a method that is owned by, I use that word owned by the class itself, the character class, and it's used as a service level method. In the same way, I'm going to skip ahead, in the same way that the math class, right? We've seen math.pal, where you can send over 2 parameters, the 2 and the 3, right? I can come in here and I want to print math.pal. Let me delete all of this. What just happened? I want to come delete all of this. If I type in print math.pal 2, 3, it'll print 8. How did it do that? We're using the math class. Math class provides to us a power method, which takes 2 parameters and it will return for us the result. 2 raised to the 5 will return for us 32, right? This is a service level method, the power method, inside the math class. Well, in that same vein, the character class has methods that it provides for us. And in fact, if I just type character dot, we can see if I scroll down, all kinds of methods in here. Is letter or digit? Is lowercase? Is it mirrored? Is it a space character? All kinds of methods available in the character class. And this is not something you memorize. This is something where if you want to know, hey, I wonder if Java or Python or some other language gives me the ability within a given class to do a certain action, to perform an operation, we want to be comfortable going to Google, pulling up the official documentation of the language, in this case Java, and checking what's available for us. So on the previous page, I showed some sample methods, checking if it's a digit, if it's a lowercase character, an uppercase character, and so on. And here are some examples. Pretty straightforward. We can just check if a given value is uppercase or lowercase. I'll type that out here. Let me just type in character dot is uppercase. Uppercase right here. And let's send over the character lowercase w. That should print false, and indeed it does. So notice, how did we call this is uppercase method? We called it by saying, hey Java, I want to access this cool method is uppercase inside your character class that you provide for us. And then we send over to that method a parameter, in this case, a lowercase w. If I put in a capital G, this will print true because clearly that is an uppercase letter. We can check uppercase, lowercase, digit, letter, and many, many other things. So back now to data types. We talked about primitives, how Java has primitive data types. That's one category. And there's 8 primitives: int, double, boolean, char, long, float, byte, and short. We've seen 4 of those in detail now. Int for an integer, double for real numbers, floating point numbers, Boolean for true and false, and now char for single character values. What about non-primitives? What are these non-primitives? Those are reference data types, aka objects. We've seen some already. A scanner object. We've seen a string object, although we haven't broken that down like we're about to. So we've seen some objects already, and these objects, they are created from what we call blueprints. Just like a construction company has a blueprint from which they then build or construct many homes, we will learn in that same vein, Java has a blueprint for many of these different types of objects that it can create. And then from that blueprint, it then creates the object. Now, the blueprint is my word because it makes sense. It's something we can all understand. We've heard that term before. A blueprint in Java is called a class. So one more time, a blueprint in Java is called a class. And let's look at the scanner as an example we've already seen of a non-primitive data type. And we see here, this is an assignment statement that will once again break down. What is that assignment statement doing? On the right side, it says new scanner system.in. What that does is it says, yo Java, make me a scanner object. How does that work? It's going to go to the actual scanner class and it's going to construct for you an object that we normally depict in a circle, as you can see here on the screen. On the right of the screen, we have this scanner object that's been created, and the system.in basically says scan from the keyboard. Make this new object, it's going to scan from the keyboard, and then look at the left side of that assignment. Save that new object into a variable called in, but it's actually more nuanced than that. We're not saving the object itself into the variable in. What we're doing is we're saving the address of that object, because that object was created. This scanner object was created. It's in memory, and we're saving the address of that object. Where it's found in memory, we're saving that address inside the variable in. And what is the variable in? It's our scanner variable. It's the data type scanner, and it stores an address. In Java terminology, we say reference, but it stores a reference or an address of that scanner object. Now, because that scanner object was made from a scanner class, from the scanner blueprint, that object has many predefined methods we can use, and we've been using them. .nextInt, .nextDouble, .next, nextLine, hasNext, and many more methods that are available to us. How do we invoke those methods? By using the variable in that we made, such as in.nextInt or in.nextDouble. So in that same vein, string is another non-primitive data type. And we've seen how to make a string variable. We have string x equals Java. Pretty straightforward. But actually, under the hood, what's going on is this. It's really string x equals new string Java. Because strings are so common, Java gives us this shorthand code above. Java does not force us to type new string every single time, but in fact, it's not just an example. If I want to type here, not print, sorry, if I want to type string name equals, give me a name, George Washington. I don't know why this is coming up as the name example, but it works. That is how we can make a string in Java. If you really wanted to feel the object-oriented portion, component of Java, you could have typed new string and make a string object like this. It's the same thing. This is identical for purposes of Java. These two lines of code are identical, and clearly the second is easier. And it's showing an error only because the word name has already been declared. Those two lines of code are identical. We should not make strings this way. The reason I'm showing you, though, is I want you to see that, in fact, strings are creating an object. So what's going on under the hood is Java's making an object a string object. It's putting this text, Java, in this example, it's putting that text inside the string object. We then save the address of where that object is found in memory. We save the address of that object inside the variable x. So now x can refer to that object. That's why it's called a reference in Java. And now what's valuable to know is that this object was created from the string class, it has many methods that can operate on it. Okay, all of that, it's not complicated. That's really something that maybe we already knew in Python, but what's really cool is that strings in Java and Python, they are super similar. Both of them are merely a sequence of 0 or more characters. And it's important to know 0 because you can have, right, an empty string. Even in Python, I could say name equals an empty string. If I wanted to make this Java, I need to put a semicolon in the string data type. So a string is in fact a sequence of 0 or more characters. Strings in both Java and in Python are objects. They are not primitives. And that's valuable to know. Because they're objects, that means they're constructed from a blueprint. And that blueprint has valuable methods that we can use to perform operations on our string. Also, strings both in Java as well as in Python are immutable. That means you cannot change the content of a string. Someone says, what are you talking about? If I have string A, let me just declare x on its own. I can then say x equals ABC, and then later I can say x equals EF or DEF. So you're wrong. I just changed the contents of that string. No, we actually did not change the contents of that string. So let me come back over here, erase what we had. What we first have here was what? We had x equals ABC. Well, that's an assignment. What just happened? We have a string object. ABC is saved inside that string object. And what is actually saved inside x is a reference that I usually depict with an asterisk. So this address that is saved inside x, it points over to the object in memory. That second line of code was, we then said, okay, x equals DEF, semicolon. Well, this is an assignment here, right? So we start on the right side of the assignment. What is that? That's a new string object. It has inside it DEF. And then after making that object, it's an assignment, so we need to assign that object, in this case, the address of that object into x. So now, x, now let me just change color to be consistent. So now x points directly over to the object, the new object, and that is gone. And in fact, we're going to learn that Java, with respect to objects, has no mercy. Since no one is pointing over to this object at all, it gets completely deleted by the Java garbage collector and it's gone. So we did not edit the contents of our string. What we did is we simply made a new string. So in Java, strings are absolutely immutable, and that's also true for Python. So here's a reminder from Python. We make a simple string called SumString. I set it equal to object-oriented programming. And then I perform some Python methods, some string methods. I say SumString.upper, it prints the uppercase version of that string. SumString.lower, it prints the lowercase version of that string. SumString.indexE, what that does, again, this is Python. I'm not here to teach you Python, but I want to show you how this code, next page, to this code in Java. And it's very similar methods from the upper to uppercase in Java. Here we have SumString.lower. Here I have SumString.toLowercase. Here in Python, we have SumString.indexE. What that does in Python is it looks for the first occurrence of the letter E, which was right here on the word object, which is at index 0, 1, 2, 3, at index 3. So it will print a 3. That was in Python. Now in Java, it's called index of. I like the name of that one better because it's like index of the E. What is the index of the first E? Right here at index 3. You could send a single character in Python. You could send an entire word. So this is saying, hey, if the word oriented is found, which index is it found at the beginning? It's found right here, this capital O of oriented at index 7. Same thing for Java using index of. Finally, string.split we've seen. What does string.split do in Python? It takes this 3-word string, and because we're splitting with a space as the delimiter, I mean, that's the thing we want to split by. So we're splitting based off of spaces. So this string comprised of 3 words is going to be split into 3 strings. And now we will have a list in Python, a list with 3 strings inside it. Pretty similar to Java. We're not using a list, now we're using an array. So the data type here is an array, which is those 2 brackets right here in Java. This is an array of size 3 strings, and how do we do it? We simply did SumString.split. The only purpose of these 2 slides were to show you how similar these 2 languages were with respect to the methods on strings. Now, I cherry-picked those methods so we could see how similar they were. There's so many more methods, though. Many more methods in Python, many in Java. They don't all overlap. Different methods will do different things. And we're now going to look at the string type in Java in more detail. So how do we declare a string variable? As we did right here. I could say string name. Then I can initialize it. String name equals what I say here, Bob Smith. Super creative. That was sarcastic, I hope you know. I declared on one line, I initialized on the next. As you know, we could have declared and initialized in one go. So we've now created this new string. What's most important is to understand the different type of methods available to us. We've seen 2 uppercase, 2 lowercase, string.length. What does that do? That will simply give us the length of the string. Name.length, this will print the length of Bob Smith, which is 9. Let's make this just Bob so you can see it is length 3. Now in Python, what would that have been, right? This would have been len of name. It was not a string method, it was just an operation in Python. But in Java, it's name.length. All of these are methods that are part of the string object. Now, what's different from the character class we had instance methods. We had static methods that belonged to the entire class itself. These methods for string objects, these are called instance methods. Remember, this string, it's a blueprint. This string class, it's a blueprint. And from that blueprint, we're going to create many different objects. These objects are also called instances. Those are synonymous. So I can say I made a new object from the string class, or I made a new instance from the string class. In these string methods, they operate on a particular instance, right? So if I were to say string name, I'll call it string X. It's a horrible variable name, but just it makes this easier. If I were to say string X equals Bob, and then I say let's print x.length, and here, if I were to say string y equals Michaela, and then I want to print y.length, if I were to ask you, when I print x.length, what is the result? And then when I print y.length, what is the result? Everyone will get the correct answer. We will see that x is going to be length 3, clear, and Michaela is going to be 0, 1, 2, 3, 4, 5, 6, 7. When we print y.length, we will get length 7. Everyone will get that. No ambiguity. So that then brings us back to the point. This .length method, it operates on a particular string object. Which string object? Michaela, because Michaela is the object is a string object saved into y. It's really the address of that object that is saved into y. Bob represents the address of the object saved into x. The point is that if I printed y.length, no one would have expected that to print Bob's length, right? Because Bob is a string whose address is saved in x. Y is for Michaela. So the point here is that these string methods, they are intrinsically connected to a particular object, to a particular instance, if that makes sense. That's why they're called instance methods. Whereas that character class, if I want to then print character.isDigit, this isDigit method right here, it's expecting a parameter. Here it's going to print true. It's expecting a single parameter, but this isDigit method, it's not connected to a particular object, right? Because I didn't make an object of type character. It's not connected to any object. It's just a service method. It's just a service level method that's available inside the character class to serve you and to serve your programs. So we then send to that method a parameter. In comparison, this .length method on a string, this is a method that is intrinsically connected to a particular instance, a particular object. This .length right here, it's connected to this particular object Y. This .length is connected to this particular object X. Hope that is very clear to understand the difference between a static method, which is a service level method, versus an instance method, which belongs to a particular instance. So here's the length method we've seen. What about getting characters from a string? That's super easy to do in Python, as we've seen. Given this string computer, well, let me back up and look up here. Some string equals face. We likely recall that the F is at index 0, the A is at index 1, the E is at index 3, right? So here, if I want, given a string computer, and I print S at bracket 0, what is that going to print? It'll print C. S at index 3 will print the P of computer. If I wanted to print the R, how do I get to that R? Well, most languages, you have to say S at the index, the length minus 1, which works in Python. If you take the length of computer, which is 0, which is 1, 2, 3, 4, computer's length 8, minus 1, index 7 will give you the R, right? Because we start at index 0 up to index 7, which is length 8. Now, Python's cool because if you really wanted that R, we don't need to do all of this, right? We could have just said S bracket and put minus 1 in the bracket because it goes backwards in Python, as you know as well. So there's your Python reminder for getting individual characters from a string. How does it work in Java? All of this in Java is with methods. So given a string, we want to access individual characters. Well, we have a char@at method to do that for us. So here, erasing all of this, if I want to print, I don't like Bob. I'm not very creative. I'm going to go back to Michaela again. And pardon me if I'm misspelling. There's so many ways to spell Michaela. So if I want to print the K, I would say x dot char@, and then in parentheses, I need to put the index. So where's the K? The M is index 0, the A is index 1, the K is at index 2. And that would give me the K. Or if I wanted to print the very last value, let me just put A, B, C, D, E, F, G, H, I, get J, K, L, M, N, O, P. I want to print the P. But I don't want to go count all the way down to here and see, well, what index is that? So instead, I just say x.length minus 1, as you know. So this will give us the character at this index. It'll take the length minus 1, and it'll print for us the P. Or I could have printed other indices. So here, we're simply showing you in more details. Here we have a message, welcome to Java, saved in the string shown here on this page. String message, welcome to Java. Just giving you a reminder that every letter is saved in its own index of the string. The length of that string, as we see, is 15, starting at index 0, going all the way over to index 14. And we can access each of the individual characters. More methods. We have a concatenation method that allows you to glue two strings together, which is kind of unnecessary. It's kind of weird. Like if I say string x equals ABC. And then, let me come back to here, string y equals DEF. Java gives us this method. Let me say string z equals x dot concat y. And now let's print string z. This concat method simply glues those two strings together. And the reason why I say that's not necessary, because really, let's make another string, I'll call it w, equals, I could have just said x plus y in Java. Because in Java, the plus sign, it's not always addition. Same thing in Python. Sometimes it's concatenation. But the difference is that in Java, we can concatenate both strings as well as numbers. But here it's strictly strings. But here I can just use concatenation, the plus sign, and I don't actually need to use this concat method. So I'm going to print just the string w to show you that we get the exact same output. Nevertheless, that method exists. Something new, as we've seen, that you can concatenate, as I mentioned, both strings as well as numbers. So here we have string s equals chapter plus 2. What is a string plus 2? Well, it's going to be a concatenation. So in short, if you ever see in Java a plus sign with something over here, and then you have, I should put that as an underscore, if you have some stuff over here, you got a plus sign, and then you got some stuff over here, and you want to know, is this going to be addition or concatenation? The answer is simple. Look at the left and look at the right. If both things are numbers, it's going to be addition. But if one of the two things is not a number, it will be concatenation. If I say string x equals ABC, and then I say int y equals 8, and then I want to print x plus y. What is x plus y? What is going to print? It's going to print ABC8. It just concatenates those two things together. It cannot add them because clearly you cannot add a number to a string. Also, we can concatenate a string with a single character as shown below. Supplement concatenated with the single char primitive data type B will simply give you supplement B. Also, we can use the augmented concatenation, the plus equals. Just like if I have a 5 and I say x plus equals 1, that becomes 6. Well, in that same vein, if I have this string message equals welcome to Java, message plus equals, and Java is fun, I print the entire message, welcome to Java, and Java is fun. So you can even use a plus equals for that. This is more information about concatenation. If I is 1 and j is 2, what is the output of the following? I plus j is plus I plus j. You might be thinking that's going to be plus 3, right? I plus j is, it should be 1 plus 2 is, should be 3, right? Well, in fact, this is not going to give you 3. Let me just walk through that very quickly. Int a equals 2. Int b equals 3. If I then print a plus b is plus a plus b, what's going to happen is we have two plus signs, right? And because those are both on the same level of your order, that's not the right word to use here. Okay, full disclosure, I had to pause that video because I could not get the word precedence in my mind. Wow. They have the same precedence and priority, right? I wanted looking for the word precedence. So this plus sign, we have two pluses. They're clearly the same. So we're going to go, therefore, it's left associative. We're going to go from left to right. This is how Python, how Java would evaluate this. So first, Java's going to say, cool, I need to take this and I need to plus it with this right here. So is that going to be addition or is it going to be concatenation? Well, we see we have a string with, what is A? A is 2. A string with a number, but that will result in a string. So it's going to print A plus B is 2. So now we have this string, a plus b is 2, and we need to concatenate that string now with this, which is going to be 3, and that is going to be the result, which is not the intended result. So notice this says a plus b is 23. So how would I get a plus b is 5, which was the intended result? I'd have to use parentheses. So now this, as you know from the precedence rules, PEMDAS, parentheses are done first. So first we're going to get a plus b, and that's going to give us a 5, right? Because all of this is really going to be 5, which will then be concatenated with that result. So important concatenating strings and understanding how concatenation works. 2 lowercase, 2 uppercase, we've already seen those. Trim, what trim does, it just trims out white space. I'll show it to you. It's just not as commonly used, to be honest. There's not many, unless you're reading from files a lot, there's not too often we use it. Nevertheless, here I give this string, and let us make another string, y equals x dot trim, and then let's print x, and let's print y. So we can see here's x, and I'm highlighting it to show all the extra space that got printed, right? But here's y. It's been trimmed out. And in fact, I could print the length of y is y dot length. And I'm just going to call its length method, and we see the length of y is 2. So trim just trims out the white space. How to read a string from the console. We've already seen this, so I can go quickly through it, but I'll just show this one instead of coding it. I make a scanner. If I say enter 3 words separated by spaces, string s1 equals n dot next. So the dot next is how you read a single string, not a line, a single string. Dot next, I use it again to read the string 2. Dot next, I use it again to read the string Java. So actually, I am going to code something. It's worth showing you this. Scanner n equals, scanner n equals new scanner system dot in. Let me import. Let me delete all these comments that we don't need for the moment. And so, yeah, if I make this, if I have the user enter the input, welcome to Java, right? Would they say, enter 3 words separated by spaces? Fine, we'll prompt them. Enter a message. Let's do that. Enter a message. Let's get rid of the ln so they can enter on the very same line as the print statement. If I then said string, oh my gosh, I cannot type. String input line. I'm saving a variable, the variable name input line, because it's very descriptive. If I said, let's read the entire line of text from the user, and then let's just print that line of text out. So I said, you inputted this. So now let's run this code. And if they type in, welcome to Java, we scanned the entire thing they inputted. We scanned it in one go because we used .next line. So really, I'm explaining this slide and the next slide in one go. So here, if we use .next line, this is closer. So this is like Python's input command, which will scan the entirety of the line. You then, as the developer, need to split that line and do what you want with it. That's how Python works. Java also gives us a next line, which will scan the entire line in one go if that's what you want. But if you know that the user is strictly going to give you 3 words, and you already know for a fact they're going to give you 3 words, you could just say word 1 equals n.next. Next does not scan the entire line. What next does is it scans only until it sees a space. So it'll scan just the word welcome, and it'll stop scanning once it sees a space right here. It'll stop scanning. So then, when I type string word 2 equals n.next, it'll scan the next word 2. And then, finally, string word 3 equals n.next, and we've scanned the word Java. So let's just now print this. You inputted this. But now I have to do one at a time. Word 1 plus word 2 plus word 3. And I'm not putting any spaces between any of those. And welcome to Java. And it prints everything. So that's what .next does. And we've already seen .nextInt. What if you knew they were going to enter 3 words followed by their age? Equals in .nextInt. How does that work? As you know, age, they're entering their age as 19. So now they say, welcome to Java 19, right? So the next scans welcome, the next scans the 2, the next scans the Java, and finally the 19 is scanned by the next int. So what's nice is that we can do one word at a time, one integer at a time scanning. It's not just a one-off like in Python. You have to do input scans the entire line, period. Now we have next line. We could scan the whole line, but if we don't want to scan the entire line, instead we could just scan just individual words until we see a space. So that's been covered. So here's a good question. A good question would be, what if we want to ask the user to enter, we want to scan a single character, and we want to save it into a primitive char value. So if we want to ask them enter, right? Enter Y or N. Enter your choice, for example, Y, N. And we told them only enter Y or N, and let's trust that they're going to do that. So ultimately, we want to scan their choice of Y or N into a character choice, the primitive character choice. So because ultimately they're really just going to enter a Y, or they're just going to enter the character N. So how do we save just the character from their entry? Because what happens in Java, all of these in.next or next line, it scans a string, not a character. So what we could do is, if we know for a fact they're going to enter a single character, we could do this. We could do in.next dot char at 0. Is that okay? Did we just have our minds blown and we're like maybe confused? What else? I don't have like a mind blown thing I need to get on there. So is that okay, or does it work for us? What just happened if we break that down? Well, imagine the user entered a Y, right? Well, the .next, what it does in .next is it scans that Y as a string, which we have here. Here's a string. And then when I say .char at index 0, well, this is a string right here. And what character is found at index 0 of that string? In fact, the character Y was. So this is how you could scan a single character from the user. You could use a .next or a .next line, scan the character, and then just get at index 0. Comparing strings, this is new for us. How do we compare two different strings? Python is the winner here. Python, you can literally just use the normal comparison of equals, right? Like if I say int A equals 3, int B equals 3, print A equal B, that would print true or false, correct? That's going to print true. I make B 4, that'll print false, right? But what about in strings? You can't do equals, because if I have a string, imagine this, string x equals, I'm going to use new on purpose, and I won't cover y for the moment, but new string of ABC, and then string y equals new string of ABC. If I check if x equal y, you might be thinking, yeah, it's the exact same string. It should print true, but it prints false. Why does it print false? Can you think about why it may print false here? And in fact, the reason why is because remember what is getting saved into X. What's actually getting saved into X is an address of this particular object. And that's different than the address of this object, even though the contents are the same. So therefore, with that in mind, since they're two different addresses, which is going to give us false, because clearly it's a different address, and we can see that now, how do we check if two strings are pointing, if the contents of two strings are equal? We have to use a method, and all of these things are methods on string objects. So Java gives us the equals method. So if I say x dot equals y, that will check the contents of the objects. It'll go to the object, look inside it, and see, hey, what are you? You're ABC, cool. Well, what are you? You're also ABC, great. And now it prints true. So we have to use the equals method to check for equality. Here's some examples. String S1 equals welcome to Java, S2 is welcome to Java, S3 is welcome to C++. If I do S1 dot equals S2, that'll be true. S1 dot equals S3 will be false. What about comparing strings? Not equality, but now we want to check which string is bigger than another string. Well, what does that mean, bigger? That's kind of weird. Well, it is weird, but if I were just to give you the string A and then a string, let's call it str, string 1, I'll call it S1. So S1 and S2. String 1 is A, string 2 is G. If I were to ask you which is bigger, well, you would guess G is. Or if I were to ask you A versus B, which is bigger? Well, actually, A has the ASCII value 65. B has the ASCII value, wait for it, 66. It's just one bigger. So B is, in fact, bigger. B is absolutely bigger. There's no doubt. If I give you W and I give you Z, which is bigger, string S2 is bigger. It has a larger ASCII value, right? A larger Unicode value. And how do we do this in Java? We use the compare to method. So if I say S1 dot compare to S2, what this compare to method does, let me make this an A and a B, and let us print this and see what it gives us. It gives us a -1. What it does is it compares this string to this string, letter by letter. And the first difference it finds, it stops comparing, and then it sees what is the lexicographical difference between those two values. It looks at the Unicode values and it subtracts them. So here, if A is 65 in Unicode, B is 66, what's 65 minus 66? A -1. If I were to make this a C here, you might guess correctly that will be a -2. The difference between an A and C is -2. Here we have a -3. Let's pick another two letters. How about N-O-P? I got to think Q-R-S. So from P to R, P-Q-R. That should be a difference of 2, and in fact it is. I hope you follow that. So we can use the compare to, and we can see if I compare this string to this string S2, and if I get a negative number, so here, a negative result tells me that S1 is smaller. A positive result tells me that S1 is larger than S2. So if I had put Z to R, this will give me a +8 because Z is 8 values larger than R in Unicode. And let me also show you, let's say this was A, B, C, D, E, F, G, underscore, it's a character, C. And here we have A, B, C, D, E, F, G, underscore, E. So these are two strings. What's going to happen? The compare to method is going to look at the A versus the A. They're the same. The B versus the B, they're the same. It's going to do this character by character. The G versus the G, they're the same. The underscore versus the underscore, they're the same. And then we get to the C versus the E. Oh, they're different. What is the difference? It's 2, a -2 in particular. And so this one is smaller lexicographically. That's how compare to works. So there's many methods you can use to compare two strings. I just showed you compare to. Let me also tell you, what if the two strings are the same? It'll give you 0, which is the difference, right? So that actually could be used for equality as well. If the result of the compare to was 0, we know the two strings have the same contents. So we can use the equals method. We could use the equals ignores case, which is what we more commonly use, because what if you want to check if two strings are equal, but you don't want to count case, right? So we could just print here S1 dot equals S2. That would be false because those two strings do not equal each other. But if I do S1 dot equals ignores case S2, that'll print true because in fact those two strings do equal each other when we ignore uppercase and lowercase. More string methods. Compare to, starts with, end with. If I go through every single method, forget Java, just in Python, if I went through every single string method in Python, we'd sit here for 2 hours. And you don't need to do that because you don't memorize these things. You only look them up when you think you might need them. So what if I had this program, order two cities, ask the user to enter in two cities, and we want to order them correctly using the compare to method, right? So here is a running of the program. We ask for the first city. Let's say they enter New York. Second city, they enter Boston. The output is the cities in alphabetical order are Boston and New York. So how did we do that? Well, the first thing I wanted to point out is notice since we're allowing a city to have two words like New York, we need to use the next line and not next, right? Because if I had used just dot next, it would have scanned just the word new. And then when I'm thinking I'm scanning the second city, it'll actually give me York, which is all kinds of busted. So because we know that they're possibly going to have a 2-word or a 3-word city, we want to scan using next line to consume the entire line of input when we're asking for the city name. And then when we ask for the second city name, again, we consume that entire line of input. And here's the solution. Into the first city, we use the scanner, in.nextLine, the next line method of scanner, and we save it into city 1. Enter the second city, in.nextLine, save it to city 2. If city 1 dot compare to city 2 is less than 0, and what do we say if we get less than 0? A negative result tells us that S1 is smaller. Then we're going to print the cities in alphabetical order are city 1, city 2. Else, the cities in alphabetical order are city 2, city 1. It's not an exciting program, but it allows you to see how compare to works in Java. So I want to see what we have left here. Obtaining substrings, and then this is checkpoint, and I think that will be the end. So about 5 more minutes. Okay, so here, let me come back. Obtaining substrings. So how do we get a substring in Python? Super cool, using the slicing operator, which makes it nice. In Java, it's the same concept, but now it's with a method. So whereas in Python, if I gave you some string S1, and I said it was A, B, C, D, E, F, and this was Python, if I wanted to just print CD, does anyone remember how to print that? How would I print just the CD? I would have said S1 bracket, there's going to be a colon here, right? And we put some value here, and we put some value here. So what value needs to come on the left side? It has to be the start index. And on the right side, it has to be the end index plus 1. You have to go 1 index more. So if I went from C to D, in Python, it would be 0, 1, 2 is index C. So this would be a 2. The D is index 3, so therefore I have to put 4 in Python. This is how you do that in Python. In Java, it would be s1.substring 2, 4. That's it. It's that simple. So if you understand Python, it translates rather succinctly to Java, that we would just use 2, 4 in Python, now 2, 4 in Java to obtain a substring. Finding characters within a string or within a substring, just like Python gives you many methods for index or for find, Java gives you many methods here. I'm not going to go through all of those methods. That would be taking us hours and it's unnecessary. Just know that these methods are available for you and there's different nuances between them. So whenever you need to find a character in a string, you'll just have to go look up, hey, what method does Java give or does Python give? And you look it up and you see and you read how to use it. Here are some examples. Welcome to Java.index of W. It returns, of course, that particular index 0. Welcome to Java.index of, let's just say come, C-O-M-E. That's going to give us this right here at index 3, starting with that word, and so on. So those are finding characters in a substring. A practical example would be, what if we ask the user to enter their full name, and then we want to scan their entire name, but then split it, right? We want to find a space. What if we didn't want to split it? If you didn't know how to split, if you didn't know how to split, you scan their entire name, which includes a space. So then you'd have to find the space using index of, and then use substrings for the rest. And here would be a solution. If I said string s equals Kim Jones, s.index of space, here I'm getting the index of that space, and now I can use that index k, where the space is found, to get just the substring of the first name or just the substring of the second name. Final thing is converting between strings and numbers. That Java gives us these integer.parseInt and double.parseDouble to convert a string into a number. So to convert a string into a number. So given this number 152, I can use this parseInt method, which is inside the integer class, to save or to parse out of that string this int value. And that would be analogous in Python to if I were to say int input, and we scan a line from the user, we ask them to enter an integer, we scan the input using input, and then we convert it to an int. Well, in Java, that's parseInt, which is inside the integer class. So here it's integer.parseInt 152, we save it to value. Or double.parseDouble of this string, we save it into a double value. And that's it. That's all we're going to cover. The last thing here is just simply says how you change a number into a string. It's really just a quick and dirty hack. If I got the number x equals 7, and for some reason, I need to print that as a string, I could say string s, or sum, I'll just call it sum string, equals x plus an empty string. This is an empty string, right? It's a string. There's nothing in it. Well, when I do x plus empty string, that's no longer addition. That's concatenation. And now this becomes a string with the value 7. So that's a lot. This is an 80-minute video. Who's going to consume this in 80 minutes? I hope no one. I hope this takes about 2 hours to consume properly. A lot of information in here. Some of you are like, bruh, no, 80 minutes. Not cool. I hear you, but this is important. None of this stuff is none of it's not even challenging, not even particularly challenging, not challenging at all. It's just a lot of information, in fairness. It's a lot of information, which is why I'm stopping the video now, because there's 20 more slides. It's only about numbers, number systems, the math library, and we don't want to get into that right now. That'll be saved for a different video. It's been a ton of fun. Reach out as always if you have any questions.